In this video, we're going to learn how to draw Lewis structures with the erase electrons method. And what you have to first do is count how many valence electrons are in each compound. So water has 2 valence electrons for the hydrogens altogether, because each one has 1. And then the oxygen has 6. So altogether, that's going to be 8 valence electrons to use for bonding. So the first thing you do is you draw each element. You connect one time between every one that needs to be connected, and you put pairs of electrons around all the ones that would follow the octet rule. In this case, it's only oxygen. You would not do it around hydrogen, because hydrogen doesn't follow the octet rule. It only needs to have 2 electrons altogether. So now what you do is you count how many electrons you have. In this drawing, we have 2, 4, 6, 8 electrons, and we were allowed to have 8. So we're good, and the drawing is complete. If we're going to do carbon dioxide, we'd take carbon, which has 4 valence electrons. Oxygen has 6, but there are 2 of them. So 12 plus 4 is 16 electrons. So we have 16 valence electrons with which to work, and we're going to draw a C and an O and an O. You make a single bond in between each one, and then you draw pairs of electrons around each atom until they all have 8 electrons. So now what we're going to do is we're going to count how many electrons are total. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons, but we're only allowed to have 16. So what you do is you erase 2 pairs, one from each atom, and then you draw a bond instead. So I'm going to erase this and erase this. So I erased 4, but I'm redrawing 2 by doing a double bond. So now this O has 8, and this C still has 8. And this O still has 8. However, I don't have the right number of electrons because I have 2, 4, 6, 8, 10, 12, 14, 16, 18, and I need to only have 16. So I'm going to do the same trick, but do it with the O on the left side. So I'm going to erase this, and let's say I erase that, and then I draw a bond instead, and that's going to be a double bond as well. So carbon dioxide's final structure is going to be 2 double bonds between the C and the O's. Lastly, we have the SO3, so we're going to add up 6 for sulfur, and we're going to have 3 times 6, which is 18. I'll write 3 times 6 so you see that, and that's going to be 24 electrons altogether. So again, you draw the S, you draw the O, you draw the O, you draw the O. You make a single bond between each one, and then you draw 8 around everything. And don't forget to draw a pair around the S to make that have 8 as well. So now let's count. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons, but we're only allowed to have 24. So we're going to have to erase 2 pairs of electrons. So I'll erase the S ones and the one on the O on the right. And I'm going to make that into a double bond. And now I have 24 electrons, and I'm completely stable in that way because everything has 8 electrons. Also, this has resonance. Resonance means you could draw the same structure in several different ways. And so the double bond could be on the right, it could be on the left, or this could be on the top as well. So this has 3 resonance structures as drawn. This has no resonance structures because you can't switch anything, nor can this have any resonance as well. And this is the erase electrons method.